Welcome! In this mini-lecture, we'll cover the key ideas in sections 2.1 and 2.2. We begin with the definition of a statement. A statement is a sentence or mathematical expression that is either definitely true or definitely false. So let's look at some sentences and determine whether they are statements, and if they are statements, whether they are true or false. Our first sentence is, there are exactly 5 prime numbers less than 10. If we think about the prime numbers less than 10, there are 4 of them, so there are not 5. So this is a statement, and this is false. 11 is a rational number. Well, 11 is a natural number, and the natural numbers are a subset of the rational numbers. So this is a statement that is in fact true. 0 is a natural number. If you remember from our discussions previously, natural numbers are the counting numbers, the numbers we first learned to count with. They start with 1. So 0 is a natural number, is false. Han Solo is dreamy. In this case, our sentence is not true or false. It's an opinion. So this is not a statement. What time is lunch? There's no way to determine that this is true or false. It's a question. So this is, again, not a statement. Dr. E ran a 5K race on a day when the temperature was -7. This is in fact a statement. You may not know whether it's true or false, but if you look at Dr. E's racing history, you could find that she did in fact run a race when the temperature was -7. So this statement is in fact true. Often we're interested in putting statements together. The first way that we're going to put statements together is with and. So let's look at a compound statement that's joined with and. In this case, we have the doctor travels in a TARDIS, and 13 is a composite number. 2 statements joined by and. The way we will denote this is each statement will be given a name. In this case, we'll call our first statement P, our second statement Q, and symbolically we will write P and Q. This symbol is wedge in LaTeX. Now ultimately, we're interested in whether this statement is true or false. So we need to consider all possibilities for both of our statements and how they are put together. So we have P, we have Q, P and Q. Now, P could be true and Q could be true. P could be true and Q could be false. P could be false and Q could be true, or both statements could be false. In each case, we examine now that if P and Q are both true, then the overall statement is true. If P is true and Q is false, that makes our overall statement false. If P is false and Q is true, again, the overall statement is false. If both are false, also false. So if any part of a compound statement that's joined with an and is false, then the whole statement is false. In this case, the doctor travels in a TARDIS is true. 13 as a composite number is false. So our statement falls into this line of the truth table, meaning that the overall statement is false. Another common way we combine statements is with or. So again, we'll look at an example. You can have ice cream for dessert, or you can have a cookie for dessert. Now, certainly in everyday language, we would not talk this way. We would say you can have ice cream or a cookie for dessert, usually suggesting that you can have one or the other, but not both. That's an exclusive or in mathematical language. In mathematics, inclusive or means you could in fact have cookies and ice cream. So again, let's consider the logic here. We would write P or Q. Our symbol here is V in LaTeX. And our truth table, P, Q, P, or Q. Whenever we have two statements, there will be 4 possibilities. So a quick way to enumerate them is to quickly list 2 trues and 2 falses in your first column, then alternating true and false in your second column. This captures all 4 possibilities of when P and Q are true. So, as we noted before, if any part of our statement is true, the overall statement is true. So in this case, P or Q is true when both are true, when P is true, when Q is true. But if both of them are false, then our statement is false. So, if you can have ice cream or a cookie for dessert, you're going to be a happy person. Lastly, we're going to look at not, the negation of a statement. So perhaps here we have the statement, teachers are paid lots of money. That would be our statement P. So not P would be the statement, teachers are not paid lots of money. And in this case, our truth table, there's P, there's not P. P could be true. P could be false. If P is true, then not P has to be false. And if P is false, then not P has to be true. There's only one statement, so there's only 2 possibilities for the statement to be true or false. In general, the number of possibilities that you will have will be 2 to n, 2 to the n, where n is the number of statements that you have. So far, we've only looked at having 1 or 2 statements being put together for our truth table. That concludes our brief lecture on 2.1 and 2.2. Thanks for listening. Have a great day.